Let's look at measures of center, mean, median, and mode. How old was the typical signer of the Declaration of Independence? Was he a young man, a middle-aged man, or an elderly man? Here are the ages of the 56 signers of the Declaration of Independence. 40, 53, 46, 39, 38, 35, 49, and 50. So what was the age of a typical signer? Given a set of data, there are different ways we can find a typical value in that set of data. We could find the mean, which is also known as the average. To find the mean, we add up the values and divide by the number of values. So we would add up 40 plus 53 plus 46 plus 39, plus 50 divided by 56, the number of values. And we end up with 2493 divided by 56, which is about 44.52 years old. More generally, to find the mean of the set of values x1, x2, x3, x of n, so in other words, the x1, x2, x3, those are the values, like the ages. We add up the values and divide by the number of values. So in this case, the mean would be x1 plus x2 plus x3, plus x of n, divided by n, the number of values. What symbol do we use to represent the mean? It depends on whether we're referring to a population mean or a sample mean. Now, population includes everyone. A sample includes just some, not everyone. The data set includes every signer of the Declaration of Independence. So we have a population, not just a sample. We use the symbol for the population mean, which is the Greek letter mu. We pronounce that mu. In Greek class, they say mu, but in math class, we say mu. So mu is about 44.52. That's the mean, population mean. On the other hand, suppose we want to know the mean height of adult males in the U.S. We can't measure all of them, so we'd measure a large sample of them. The data set does not include every adult American male, just a sample of them, so we have a sample, not a population. Population's everybody, sample is just some of everybody. We would use this symbol for the sample mean, which is x bar. So we say x bar. The CDC, for example, Centers for Disease Control and Prevention, measured 5,647 males in the age age 20 and over, and found their mean height to be, can you guess what it is? 69.3 inches. So in this case, we'd say the sample mean equals x bar equals 69.3. We don't know mu. We will never know mu. But if you get enough, x bar is going to be pretty close to mu. X bar is the sample mean. Mu is the population mean. But since the sample is so large, we're confident that the population mean mu is very close to the sample mean x bar. So we may as well say that mu is about 69.3. Given a set of data, there are other ways we can find a typical value in that set of data. We could find the median. Okay, to find the median, we put the values in order and find the middle value. The values are 40, 53, 46, 49, blah, 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 blah. Okay, but you got to put them in order. Don't just find the middle value when they're unordered. That's goofy. So you put the values in order. So the values are 26, 30, 32, 26, 26, 30, 30, 32, 33, blah, 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 all the way up to 70. Note the range of ages, 26 to 70. The youngest signers were 26 years old. Thomas Lynch Jr. and Edward Rutledge both were lawyers from South Carolina. And the oldest signer of the Declaration, well, the oldest signer was 70 years old. He was Ben Franklin, a printer, author, politician, diplomat, inventor, and scientist from Pennsylvania. Really an outstanding American. Read his biography a couple of years ago. Fascinating guy. Okay, to find the median, we put the values in order and find the middle value. In orders, the values are 26, 26, 30, 30, 32, 33, 30, blah, 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 all the way up to 70. Okay, so again, to find the median, we put the values in order and find the middle value. So that would be the middle value if you have 5 values. But there are 56 signers of the Declaration of Independence. If you have an even number of values, there is no middle value. What do you do? What do you think you do? Well, you take the mean, the average of the middle 2 values. That's your median. So basically, you average the middle 2 values. In order, the values are, and here they are. So the first 28 values are in red. The second 28 values are in green. So the middle 2 values are 44 and 45. So that's one. So these are the 2 middle values, 44 and 45. So the median is 44 plus 45 divided by 2, which is 44 and a half. This is almost exactly the same as the mean, which is 44.52. In general, the median is a better measure of the typical value in a set of data than the mean because it is less sensitive to outliers, that is, extreme values. Let me show you an example. Suppose I have a class with 3 students, and these are the annual incomes of the families of the 3 students in my class. 30,000, 80,000, 40,000. Find the mean and the median. Okay, the mean, you just add them up, divide by 3. You get 50,000 for the average income in the class, the mean. The median of 30,000, 80,000, and 40,000, holy cow, don't say it's 80,000 because it's the middle value. Come on, don't do that. You got to put them in order. Okay, the middle value is 40,000, so that would be the median. Okay, now suppose that one of Bill Gates' children, Jennifer or Rory or Phoebe, joins my class. Calculate the new mean and median. Well, the class has 4 students, and these are the annual incomes of the families of the 4 students in my class. 30,000, 80,000, 40,000, and care to guess what Bill Gates' annual income is? About $9 billion last time I checked. Okay, so the mean is 30,000 plus 80,000 plus 40,000 plus 9 billion divided by 4. Whoa, 2,250,037,500. That's an enormous mean. Okay, it appears that the typical family in the class is quite wealthy, but that's misleading. The typical family is not wealthy, but there is one very wealthy family in the class. Okay, now the median of 30,000, 40,000, 80,000, and 9 billion is, again, you have an even number of values, so you'd average the middle 2, and that works out to be $60,000. When we included a $9 billion annual income, the mean went from skyrocketed from 50,000 to $2,250 million, roughly. Whereas the median went only from 40,000 to 60,000. So when a distribution is skewed left or right, like we talked about earlier, the median is a better measure of the typical value, the center, because the median is less influenced by outliers. If the distribution is unimodal and symmetric, the mean is fine. It's just dandy as a measure of the center. When the distribution is skewed to the right, the mean will be larger than the median because the mean is influenced by those extreme values. And when the distribution is skewed to the left, the mean will be smaller than the median because the mean is influenced by those extreme values. So again, if the distribution is symmetric, the mean and the median will be about the same. Okay, this histogram, for example, shows the distribution of the expected age at death in the United States. If we start with a group of 100,000 people, the mean is the balancing point, and the median is the point that divides the area in half, so that the area on the left equals the area on the right. So again, the median is about over here. So here's the mode, that's the peak. The median is a little bit to the left, and the mean is more like over here, because again, with a skewed distribution like this, the balancing point might be over here, because this stuff over here would balance this stuff over here if you put the mean over here. Whereas the median, the point that divides the area from the right and from the area in the left, so that they're 50-50, half on the left, half on the right, I'd say the median is here. So again, the mean, the balancing point is more over here. Given a set of data, there are other ways we can find a typical value in that set of data. We could find the mode. The mode is the most common value. In order, the ages of the signers of the Declaration of Independence are, and there they are, the mode is, well, it's actually 45, 46, and 50, because each of these occurs 4 times.